Okay, today we cover quadratic models. It is more word problems based on quadratic things that will turn into quadratic equations. And I will point out that this is sorry, that's the wrong row, problem solving. More word problems related to quadratic equations. And this is our last day of new material before our review day for the exam. Our review day is this coming Monday. As usual, there are practice test problems in the packet and resources on YouTube and on Moodle for those problems. And then our second of two tests or exams is coming up Wednesday. So we're going to start the Thanksgiving break right with the test on Wednesday morning, okay? So this Wednesday, day before the break. It's a regular day. Yeah, you'll give thanks right after you finish this test. So the test itself is on sections. The test is on classes 19 to 34, which means it is a lot more comprehensive than any of the quests. So class 19 is all the way back here. October 20th was the day after our first test. And so everything between then and now is fair game in terms of the test, okay? 19 to 34. All right, so we took a quest last class. I just finished grading them this morning. I can show you your grade, but I can't return it to you just yet. I will do that later on during the class. But for right now, we've got more word problems to tackle. So again, on 67, we'll start way up here at the top. Lydia, could you read the daily summary, please? Okay, thank you. Let's go to Virginia for one. Keep going. Okay, so we've seen this graph before. Let's write down the coordinates of the x-intercepts. What are they? So we got -6, comma 0, two coordinates, right? And 1, 0. So we've seen that before. We could find those by factoring the original quadratic, but we'll just grab them from the graph. And so with apologies, there's part of this next line that got buried. I didn't realize it was underneath the graph until after I had printed it, but it says let's find the x-coordinate of the vertex exactly by doing something to the two x-intercepts. What do we do to the two x-intercepts to find where the vertex is? We average them, right? And so averaging is what goes in there. And that is old. We've seen that before. We average the two x-intercepts, and that tells us where the vertex is. And so let's actually do it here. So the two x-intercepts are -6 and 1. So what do I do with these two numbers? Add and divide by 2, right? That's how we average two numbers. -5/2 or -2.5. Which seems reasonable. That looks like that's where the vertex is. Okay, let's go to number 2 for Fiona. Okay, so there's the important formula for the day. It turns out you don't need to find the x-intercepts and then average them to find the vertex. We can do this simple formula, so let's see it in action. We're starting with the quadratic is listed at the top. So we should be able to pick off the values of a, b, and c. How much is a? Is 1, that's the guy in front of x squared. B is +5, c, -6. So that's the a, b, and c, old. And we're going to take the a, b, and c and plug them into this new formula in yellow. It says x is equal to -b/2a. So we just have to write down those things. Don't forget the x equals -b/2a. Negative, what's b? 5 divided by 2 times a. A is 1. So we get -5/2. which is the thing that we got when we averaged the x-intercepts. Any question on how to use this negative b over 2a? Iman, you all right? Everybody else okay? Negative b over 2a. And that just magically gets us right to the x-coordinate of the vertex without finding the x-intercepts. And if you actually wanted to know the y-coordinate, I mean, it looks like the y-coordinate is something like negative 12, negative 13. What would we do with this negative 5/2? How do you find the y-coordinate for any x? You plug it in. You have your formula up there. It says y equals x squared plus 5x minus 6. So we could plug that negative 5/2 right in there for those x's, and that would give us the y value. Yeah? It's not that b was negative 5, it's that there's a negative in front of this formula. Yeah, it's negative. I mean, you can think of it as being in front of the b. I guess you're right. I didn't technically write it according to the way the formula is written, so it was a negative in the front of the whole fraction, is what the formula says. 5 we grabbed from the b of the original. Yeah. Okay. And the nice thing about this little formula is that I'm pretty sure you already know it. I mean, at least you've seen it before. You guys know the quadratic formula, right? X equals all of this stuff. Do you see this formula, x equals negative b over 2a, in there? But it's basically just everything up to the plus minus. Right, I mean, there it is. It's negative b over 2a. Just stop after the plus minus. So you already know what it is because it's part of a bigger formula that you know well. Okay, moving down to number 3. Where are we now? Casey? Okay, for practice, write down the formula. It starts x equals our new vertex formula with a's and b's and no c's. Negative b over 2a. So we do negative what number? Negative 4, right? Because b is negative 4 in this one. Divided by 2 times a, 2 times 1. Okay. And so that negative 4 just becomes 4. Divided by 2 is 2. So the x-coordinate of the vertex is 2. Now there is hardly going to be a question that I ever ask you where it says only find the x-coordinate of the vertex. I always want both coordinates of the points that we're interested in. So what do we do with 2 to find the corresponding y value? Plug it in. So y equals, I'm going to copy that formula, but every x I'm going to put parentheses to be filled in. So all I've done is rewritten the equation. Every x became open parentheses. And what number is going in for both x's? 2. This guy right here. 2 there, 2 there. I heard the sound of some calculator covers. This is embarrassing for me. Number 2 is quite small. We can handle this. 2 squared is 4 minus 8 plus 7. Minus 4 plus 7, 3. Okay, so that means our final answer is that the vertex is 2, 3. That's it, right? Number 4, Dan. Okay, so we know there's like 2 basic kinds of parabolas, right? There's the smiley face parabola and the frowny face parabola. And the vertex is just the extreme point. In this case, is it a smiley face or a sad face? Smiley face because the A is positive, right? The number in front of x squared is positive. So is the vertex of the smiley face a maximum or a minimum? It is a minimum. It is the lowest point on the graph, right? It's the opposite if you had a frowny parabola, when the vertex would be the highest point. So in our case, this 2, 3 is the minimum point. It's the lowest point on this particular parabola. Okay, and the last one here, Sam, can you read 5?
The word maximum or minimum, we get smaller, higher to lower. For the story opportunity, there's a very good chance.
Okay, so let's go to the next page, which is where the activity starts. And I just want to highlight the words in each of these problems that say find the vertex, because none of the problems are explicit and say find the vertex, but they all have a word in them that really says find the vertex. So in this second sentence here, number 1, we see this word, right? Maximum. Maximum means find the vertex. Scroll down, number 2, find the word in here that says vertex. Largest. Right? The word vertex doesn't appear, but you've got to translate these word problems and say, oh, Ian is just being sneaky. He's just asking us to find the vertex. Number 3, when was the enrollment lowest? That's a vertex. Number 4, maximum. Okay. Now, this is easy for you now because all 4 of these problems really just say find the vertex, but on the test you're going to take next week, you'll have a whole bunch of problems all mixed together, and one of them is going to have one of those keywords that we just highlighted. So you just have to be on the lookout for any word that means max or min or high or low, anything like that. So Ian thinks he's going to fool me. He's just asking for the vertex. Okay, so work through these and raise a flag if I can help.